minus 2 equals to y2, 3, minus y1, minus 4, over x2, minus 1, minus x1. x1 is 2. Then automatically this one becomes y plus 4 over x minus 2 equals to, what is this? This is 3 plus 4 over minus 3. So here we're going to have y plus 4 over x minus 2 equals to 7 over minus 3. So this is what we are going to have, and at the end we can still resolve this further. Then to continue from here, we have y plus 4 over x minus 2 equals to minus 7 over 3. So we cross multiply. We cross multiply this. Then we're going to have 3 into y plus 4. Then we'll have minus 7 into x minus 2. Then this one gives us 3y plus 12. This one gives us minus 7x plus 14. And we'll try to restructure this. Then we'll bring everything, all what we have on the right hand side to the left hand side. So we have 3y plus 12 plus 7x minus 14 equal to 0. Then here we can write this one as 3y plus 7x minus 2 equals to 0. So this is the equation of the line. So by virtue of this equation of the line, we have to talk about another concept, another subtopic, which is known as gradient and intersect of equation and determination of the angle of the concept. So now, if you are given something of this scenario, you can be given something like this, and the question can ask you to find the gradient, and that is what we have to talk about now. Find the gradient and intersect. And intersect, you have to find the gradient and intersect. So we have to find the gradient and intersect of this equation. What we do is, we know that the equation of the line is y equals to mx plus c. So if you are able to conform this equation to look like this, we can find out our gradient and our intersect. And that is our interest. So here, the first thing to do is to make y the solve of the formula, and if you have to make y the solve of the formula, we transfer every other parameters or times into to the other side, that is the right hand side. So we have 3y equals to minus 7x minus 2, plus 2 rather. So you have plus 2, minus 7x plus 2. And the next thing to do is to divide both sides by 3. So 3y divided by 3 minus 7x over 3 plus 2 over 3. Then this can cancel this, so we have our y to be minus 7 over 3x plus 2 over 3. So automatically the gradient, which is known as our m, is equal to minus 7 over 3, and the intersect is equal to 2 over 3. We are still going to discuss the gradient and intersect effectively. Gradients and intersect. A point can be given, and 2 points can also be given. So if you have to determine the gradients, you have a plane like this where you have your x-axis and you have your y-axis. Let's say you have a point like this, like your rectangular Cartesian plane. Then you have a point on this side that goes up like this, or that goes up like this. Then you have this down. Then let's say this is P, where you have your x comma y, then this is your Q, where you have your x. This one is x1 comma y1, and this one is x2 comma y2. The difference here is y2 minus y1. The difference here is x2 minus x1. So the gradient here, which is also known as, or slope, can also be called slope, will definitely be equal to y2 minus y1 over x2 minus x1. And this same gradient of the gradient of PQ, which is change in y over change in x, is also the same thing as y2 minus y1 over x2 minus x1, which is equal to tan alpha. You can see a scenario. This formula is very, very important in coordinate geometry, because this is a formula that is also connecting the angle, because it can also be asked, having given you points, 2 points of this nature, you can be asked to determine the gradient and still move further to determine the angle between them. So if you have to determine the angle between them, the first thing you have to do is to determine the gradient. After determining the gradient, then you equate whatever the value that you have for the gradient to tan alpha, and you now make your alpha the subject of the formula, and that will give you angle between those 2 points. Gradient and intersect of equation and determination of the angle of the concept. We have discussed that earlier, but to buttress more on it, that is why I need to give you a diagram of this kind, so that you have a line passing through this, where the angle between this and this horizontal is alpha. Then let's say you have a point here P, and let's say this point is Q. Then I said that gradient, which the gradient of 2 points, or between 2 points, the gradient between 2 points, which is equal to the gradient of P and Q, is equal to tan alpha. So to appreciate this angle, this is our x-axis and this is our y-axis. To appreciate this, you can be asked that to find the gradient of or between 2 points, and also determine the angle between them. Find, is an example, find the gradient between let's say 1, 2, then we have, let's say this is your point P, and Q, we have 2, 4, example. So now you have to find the gradient between this one and ends, determine the angle between them. So let's say this is a question. So the first thing we have to do here is to determine our gradient. I will know that our gradient, the gradient of P and Q, is definitely going to be changing y over changing x. This is change, a large change, not an infinitesimal change. This is a large change, which is equal to y2 minus y1 over x2 minus x1, and is equal to tan alpha. So the first thing we have to do is to determine our gradient. So if we have to determine the gradient will definitely be equal to, what's our y2 from here? We can name the point. This is our y2, that's 4, minus y1, which is 2, over x2 minus x1, so we have 2 over 1. and that is 2. So that means the gradient is 2. Then the tan alpha is definitely equals to 2. So our alpha will be arctan of 2. So arctan of 2, we are to determine the arctan of 2. So arctan of 2 will definitely give us 63.44. Let's say it will be 63.435, which is approximately 63.4 degrees as to 1 dp as 1 decimal place. So we'll have that, and that is the formula that is connecting. So this formula is of importance because the formula can, if you have to determine the angle between 2 points, that means you have to determine the gradient first, because there is a direct relationship between gradient of the points and the angle between the points. So we have to talk about differentiation. The first thing we have to consider here is definition. So how do we define differentiation? Differentiation can simply be defined by considering 2 parameters. I got to consider 2 parameters. Let's say you have y equals to x. You have to define this. That means we are talking about the change in this, change in your y with respect to x. But this time around, this change is so minute that it can be termed infinitesimal change. And when we say infinitesimal change, we are talking about dy dx. So we have differentiated y with respect to x. Now we are going to consider an important principle here that is known as the first principle. So if you are to consider first principle, because a question can be given to you, you can be tested that you should differentiate a particular term or a linear equation. It could be a linear equation, it could be quadratic, it could be cubic, it could be quintet, or it